Introduction to XAct. Accretive's technology fills the famous gap between business performance and IT efficiency. XAct relies on the discovery of what we call dynamic complexity. Dynamic complexity characterizes any dynamic system from planetary perturbation on each from all, the impact of business dynamics on the fluctuation of IT services, the cause of surprises in economic outlook, pandemic, or meteorological forecasting. XAct is the first technology that is able to predict dynamic complexity. Its impact on business and production efficiencies determine the risk of eventual limit, chaos, or surprises, and can determine the right action to apply preventatively to avoid the crisis. It is appropriately complex, but the problems are complex, and by slashing details, you may affect the robustness of the outcome. The XAct tool display consists of two major sections: the main viewing window, which is tabbed with toolbars, and a sidebar on the left with three supporting windows for models, properties, and previews. XAct is constructed around three views: the organizational view of the business, called corporate view, the business process view of the business, called service view, and the physical implementation of the business, called implementation view. Each view can contain many levels depending on the possibility of change and the objectives of the emulation. The corporate view is hierarchical and consists of three types of object: the corporate object, the business entities, and the business processes. There is only one corporate object, and it is the top of the hierarchy. It has 5 user-assigned properties. You can view these properties in the properties window on the side once the object is selected, or you can look at them change them in the dialog. The 5 properties are name, number, which is the quantity of units handled during the window, window duration, which is the length of time that the workload provided represents, the duration type, which is the unit of time, seconds, minutes, hours, days, and the unit type, which is provided by the user, which represents what is being done at the corporate level here. So it can be customers, parcels, envelopes, users, client accounts, credit cards, whatever the user wants. So in this case, we have a corporation called My Corporate. It has 12,000 as the number, so it's 12,000 client accounts. We have a duration of 1 minute. All objects on the corporate display are connected by lines. The lines represent the relationship between the objects. So this line is connecting corporate and a business entity called cards. These lines have properties which are utilization frequency, which for this line is 80%, which represents 80% of the number here, of the 12,000 here, would be passed down to the cards as its number. Cards has a default value. Our business entities have properties. They have 3 properties basically, which is a name, a number, which in this case is 900, and a unit for this business entity, which is persons. But a business entity can also have properties where the number is a -1 and there is no unit type specified. A -1 means to inherit from the parent above. So in this case, the 900 in the cards is going to be passed down, affected by the utilization percentage of the line, and set that value there. Okay. Business processes represented by the blue dots, have 3 properties as well. So if we select trading and settlement here, we click on the properties or the edit, when we see that it has a name, it has a workload type, which is a selection of either transactional or batch, and then you can specify a duration, which is an SLA. This is specified in seconds. From the business entity, or from the business process, we can go to the service view by double-clicking on the business process. So if we open the trading and settlement business process, we will move into the service view. As you can see, the service view tab is opened, and we see within that 3 business service processes: collect trades, analyze trades, distribute trades. If we open it, each has a handle that can be clicked to open to show more detail. So you can drill down into each one of these. Service view consists of 7 different types of objects. We have service processes, we have service to services or messages, we have service tasks, we have service components, service activities, service collectors, and service insertions, as well as service starts and ends. If we drill down into Analyze Trades, we move in and we see that in the Analyze Trade, we have a service component called Execute Trade. If we drill further down in Execute Trades, we will see that we have additional service components called Trading, Settlement 1, Settlement 2, and Prepare Cleaning. If we select one of these and drill down into it, here we can see we have service tasks. In this case, there's 3 service tasks called Settlement 1 stream, Settlement 1 per unit 1, Settlement 1 per unit 2. And we can continue to drill down, and inside of that task we find a service activity. Service activity is what ties us to something occurring somewhere. In this case, it ties us to a component on a server. This happens to be a database component. So we can go there and we could see the properties here, and we can open the properties for this and see that it's associated with a component called btrade2prinv on the London Trading DC _trade server, and it's complex 0 on that server. We'll get more into detail on that in a minute. So now, if we go back a little bit, we can go into look at a few additional ones here. If we open Collect Trades, we see in Collect Trades we have a couple of tasks, and we have a message or service to service. If we check out, we also see here we have a task called Format Trades, which is a little different. It doesn't have the gears on it, it has a watch. This is a preparation task that represents time. It can be a black box, it can be an external contributor to the process, something that is not under the control but has a response time. It could be a wait time, a user think time for a human being doing something, but it represents a amount of time that is provided per request being processed through here. The message, if we select the message, we can see that it has we see that it has a producing activity of send trade and a receiving activity or consuming activity of receive B trade. We can see that the component that the message is passed between is send trade on Dublin broker terminal to receive trade on London trading DC hub. So let's go look at the implementation here so we can see going on. The implementation view shows the physical implementation of the business, as we said earlier. You can see here that locations, which are geographical locations, are represented by pins on the map. We can zoom in or zoom out of the map. We can move it around. In this case, because we're dealing with the trading system was located in London. So let's take a look at London. A physical location can have groups associated with it. It can have multiple groups. And in this case, I'm going to open the London one. So if we're double clicking on that, we see the groups that are associated with that. There are two network groups, POP MPLS type groups, and there is a data center. The data center, if I double click on and open up, we get a group view to show us what is going on or defined at that group. In the London data center, we see that we have network equipment. We have a router here, a router there. They're all connected by lines. These lines represent network connections, and they have properties on them that associate, which we can select. You can see the distance, any overhead, any error rates, the throughput, protocol if any is specified. Same with the routers, and then we have a switch, and then attached to the switch we have two servers which have storage attached to them. Let's first start by looking at storage. We can look at the storage associated with the trade server, and we select the storage properties dialog, and we can see that it has several different data stores defined. If we select a data store, we can see what a disk is assigned to that data store. The first one in the list, all disk, is a data store that has all disk associated with it. So you see there's nothing in the available, everything is listed over here. If we go to the trade server and select the trade server, we can see by clicking on the host dialog that this is a server which has only one complex being a physical machine. This node could actually represent a cluster and have multiple machines. In this case, complex 0 is a single machine with 24 processors. It is a Sun machine, Sunfire 6800 with 900 megahertz processors. On that machine, we have a server instance and only one server instance. We have no zones or it's not virtualized. We have the components that are running on that machine listed here. We see these. We saw some of them earlier. I think we saw this particular one we looked at earlier. This happens to be a database component, as we said. So if I click on the SQL button, we can see that there are several actual clusters of SQL, which we refer to as stored procedures. They may or may not necessarily be stored procedures, but they're grouped bunches of SQL. So by selecting one of those groups, we can see the SQL that's involved here. We give it a name. We have a verb. In these cases, they're direct reads on a table. They use an index. How often they are used in the cluster efficiency, whether it's prefetch or not. There is no complex SQL here. But we can go to one of these other ones and see that we have here different SQL. They're all given different names. We have direct reads, we have deletes, we have updates, inserts in some cases, but not in this particular one. We also see the tables and the indexes involved. We can go to, so basically that's SQL. Because this is has a database here, we can click on the database instance and find out information about the database instance. We see that there's a log buffer defined, which was called pool. It has 100K is the pool size, 4K pages, pages per IO. There's 4 pages per IO, and there's the disk that's associated with. We can go see the cache. We have a cache that is basically 25 meg of cache. Page sizes, IO per pages, CPU per IO. We can go to the namespace or the what do I say? Namespace or schema name, and we can see that in this case there's only one schema or namespace, and you can see all the tables that are defined in here with the you can see the cache, you can see the row length, the useful size, all this information that is provided. If I select a particular table, you can see the index that's associated with that table. See them listed there below. What I didn't show you was that you can also see up here that the type of database it is. In this case, it's a Sybase database instance, but you can select from any of the possibilities that we have set up. Different versions. We have SAP HANA, we have DB2 versions, Oracle versions, we have Database, we have Informix, we have DB2, MS SQL. So we have lots of different database types that you can select from as you build your model. One additional thing is that by selecting that, we can go in and actually edit the server's definition. So I can select complex 0 here and can do an edit of that. And we can see, we can change that server to be virtualized. We can select a different manufacturer. We can change it to a Dell and see Dell machines here and select a Dell machine from the catalog, or we could go to the universal catalog and even change platforms going to, and we could go to a mainframe here if we wanted to. So that allows us to change the actual hardware platform that this particular server is running. If we go back to the service view, one of the things we were talking about, if I go here and look at the receiving side of this message, we can see that here we can find that it's this component. We can see that there's the component again. We can see that it because I can have multiple components that are represented by this process flow on multiple servers. This is actually a drop-down list, and I can distribute the amount of work across those servers to represent that. In this case, though, there's only one component. It is running on the hub in the London Trading Center in London. I can click on the view server and it'll take me there, and it shows me that it's on this machine. And if I go here and select the properties, I can go over and I can find this right here. And if I scroll down, there is receive trade. Okay. Lastly, we can take a quick look at results. When a model is computed, we get results. And in this case, we see that there is an issue. We have a red banner here that shows us that at plan point 1, our DICOM score gets rather high. Our risk is only 45.5, but our DICOM score is 99.9, which deals with dynamic complexity. This shows things so we can see where problems exist within the different processes of the business. So an executive can look at this and can see that there's something going on with the trading and settlement process. If I open this up, I can see that basically my costs are inflated, and I have some possible network issues that are showing up here. Quality degradation hasn't gotten severe yet, but but it is increasing, so it's getting into the range. I can look at that. Look at the components here. I can see that I have a very high 37.4 DICOM score. This is used by 100% of the requests going through. Contention is 42.8. We can see time. We have data efficiency, which isn't too bad here. I can check out additional components. Let's go here and see what's going on with them by selecting additional components. We can see that the DICOM score is a little less, contention's a little less. You can see where it falls within the trading and settlement per unit 1 in trading, per unit 1 in trading and execute trade. You can see with some of these, our data efficiency is terrible on this at 57.9. DICOM score isn't too bad. Risk index is increasing. Contention is not too bad, but the data efficiency is not good here. Okay, so we can have a graphical view to show what's going on by looking at the dashboard. We can see here that as our productivity, let's go to trading and settlement, which is right here. Make it the main one to look at. If we look at trading and settlement, we can see that as our productivity is increasing, our cost efficiency is decreasing, which is a good thing. But as we get to around 900 a minute, between 900 and 1080 a minute, our dynamic complexity jumps up, which means we're starting to have a lot of contention. This would be around this is 0, 1, 2, 3, 4. This is the fourth plan point. Between the fourth and fifth plan point, things get really bad, and our productivity starts to, production efficiency starts to decline. Our cost to deliver seems to be fairly steady moving along, but then it begins to increase. And when we reach this point out here, where we're doing in the range of between 2,500 and 2,700 per minute trades per minute, our cost gets to be greater than our productivity, and we become extremely inefficient at this point. This is important information for the executives to see. For the technical folks, we have more detailed information. We can go look at the service management detailed results, and we can look at the actual detail of the individual components involved in that process. So if we go down and we find trading and settlement here, I can open trading and settlement. We can see the detail for that. In this case, we see that at point 1, Prin5V has a problem. If we look at contention, isn't too bad. It's the worst on Prin2, Prin-V, which was one of them in the list, along with Prin1, Prin-V, and also Prin3, Prin-V, which actually has the highest, which was the first one in the list. We can see the detail of these, but if we go look at, say, Prin 0.5, where we knew we had some issues where dynamic complexity jumped up, and we go look at trading and settlement here, we should see that our conflicts became substantial here. We also see that our impact by the database becomes rather large, and we can select this server and go look at the detail of that server. And we see that this one, the B-Trade 4 Prin-V is in the red. We see, same with 5. If we come look at the cache hit ratio, we see the cache hit ratio is very low. We also see that our overall hit ratio on the C1 cache is not particularly good. You want to be as close to 100% as you can be. We don't have a whole lot of problems disk-wise, but that seems to be where the problem is. or where there are issues. We also see that we have a lot of contention on a couple of network hubs, our network dealing with hub trade and also with the broker trade. So we may want to look at the network because that seems to be adding a lot to the response time. So those shows us things that we can look at. We can also see stuff by server. Service management shows it by business process. Resource management shows us by server. In this case, we're looking at a web browser in New York, but we can go look at the trade server here and see the utilization of that trade server, and we can see the components and what their consumption is, conflicts on there, and all those. That is basically it for this segment of Introduction to XAct.